For this problem, we have to figure out the secret number. We know that the secret number is an even number less than 8, so this means the number can be 2, 4, or 6. We also know that the number is greater than 4, so this means the number cannot be 2, and it cannot be 4. That leaves us with 6, so the answer to this problem is 6. For this problem, we have to figure out the mystery number. We know that the mystery number is larger than 6 but less than 12. We also know that when we count by 3, we will say this number. Let's start counting by 3 starting from 6. So we would count 6, 9, and 12. Since this number is larger than 6 but less than 12, we cannot include 6 or 12. That leaves us with 9, so the answer to this problem is 9. For this problem, we have to figure out the mystery number. We know that the mystery number is not an even number and it is between 20 and 50. We also know that the sum of its digits is equal to 7. Our last clue is that this number is divisible by 5. Using the first, second, and fourth clue, we know that this number can be 25, 35, or 45. We can use the third clue to help us solve this problem. The third clue is that the sum of the digits is equal to 7. Let's start figuring out the sum of the digits. The sum of the digits of 25 is equal to 7. So this means 25 would be our answer. For this problem, we have to figure out the mystery number. We know that the mystery number is an odd number and it is between 315 and 323. That means the number must be 317, 319, or 321. We also know that the sum of the digits is equal to 6. So let's figure out the sum of the digits. The sum of the digits of 317 is equal to 11. The sum of the digits of 319 is equal to 13. And the sum of the digits of 321 is equal to 6. So that means the mystery number is 321. For this problem, we have to figure out the mystery number. We know that the mystery number is even and it is between 966 and 994. We also know that the 1's digit and the 10's digit are the same number. Since the number is greater than 966 and even, we have to find the smallest even number greater than the 6. And that would be an 8. Since the 1's digit and the 10's digit are also the same, the 10's digit is an 8. The only number between 966 and 994 that ends in 88 is 988. So 988 is the answer. For this problem, we have to figure out the mystery number. We know that the mystery number is a 3-digit odd number and all the digits are the same. So this means the number must be 111, 333, 555, 777, or 999. The last clue tells us that the product of the digits is equal to 27. So let's figure out which number's digits have a product of 27. The product of the digits of 111 is equal to 1, and the product of the digits of 333 is equal to 27. So this means the answer to this problem is 333. For part A of this problem, we have to figure out the mystery number. We know that the mystery number is less than 50. We also know that the number divided by 5 has a remainder of 1. We also know that when the number is divided by 8, there is a remainder of 2. We can solve this problem by listing out all the numbers that when divided by 8 have a remainder of 2. We can then test those numbers by dividing them by 5 and seeing which ones have a remainder of 1. So let's start by listing out all the numbers that when divided by 8 have a remainder of 2. They would be 10, 18, 26, 34, and 42. Now let's divide each number by 5 and see which one has a remainder of 1. 10 divided by 5 has a remainder of 0. 18 divided by 5 has a remainder of 3. 26 divided by 5 has a remainder of 1. So this means the answer to part A is 26. Now let's move on to part B. For part B, we also have to figure out the mystery number. We know that the mystery number is less than 50. And when it is divided by 3, there is a remainder of 2. So that means number divided by 3 is equal to a remainder of 2. We also know that when the number is divided by 5, there is a We also know that when the number is divided by 4, there is a remainder of 1. So that means the number divided by 4 has a remainder of 1. Our last clue is that when divided by 5, there is a remainder of 4. So that means the number divided by 5 gives us a remainder of 4. We can solve this problem by first listing out all the numbers that give us a remainder of 4 when divided by 5. They would be 4, 9, 14, 19, 24, 29, 34, 39, 44, and 49. Now let's divide all the numbers by 3 and see which ones have a remainder of 2. Dividing 4 by 3, we get a remainder of 1. Dividing 9 by 3, we get a remainder of 0. Dividing 14 by 3, we get a remainder of 2. Dividing 19 by 3, we get a remainder of 1. Dividing 24 by 3, we get a remainder of 0. Dividing 29 by 3, we get a remainder of 2. Dividing 34 by 3, we get a remainder of 1. Dividing 39 by 3, we get a remainder of 0. Dividing 44 by 3, we get a remainder of 2. And dividing 49 by 3, we get a remainder of 1. Now let's test our final clue, which is that when the number is divided by 4, there is a remainder of 1. Note that we only have to test this on 14, 29, and 44, because there must be a remainder of 2 when the number is divided by 3. So dividing 14 by 4, we get a remainder of 2. Dividing 29 by 4, we get a remainder of 1. So this means the answer to part B is 29. For this problem, we need to figure out the mystery number if we follow all the clues. Our first clue is that we should cross out all the numbers that are multiples of 7. The only number here that is a multiple of 7 is 35, so we're going to cross out 35. Our second clue is that the mystery number is not divisible by 5, so that means the mystery number is not a multiple of 5. The only multiples of 5 are 55 and 10. Our third clue is that we should cross out all the numbers that are multiples of 6. The numbers that are multiples of 6 are 54 and 18. Our fourth clue is that the mystery number is not a prime, so let's cross out all the numbers that are primes. 31, 17, 2, and 11 are prime, so we're going to cross them out. Our last clue is that we should cross out all the numbers with a factor of 4. 32 and 8 have a factor of 4, so we're going to cross them out. That leaves us with 22, so the answer to this problem is 22. For part A of this problem, we have to figure out the mystery number. Our first clue is that the mystery number is a 3-digit even number, so this means the number has 3 digits, and the last digit must be 0, 2, 4, 6, or 8. Our next clue is that the tens digit is greater than the number of quarts in a gallon, so that means the tens digit is greater than 4, so it must be 5, 6, 7, 8, or 9. The third clue is that the ones digit is greater than the tens digit, so that means the ones digit must be greater than at least 5, so it must be 6 or 8. The fourth clue is that both the hundreds digit and tens digit are odd numbers, so that means the hundreds digit must be 1, 3, 5, 7, or 9, and the tens digit cannot be 6 or 8. The next clue is that the ones digit is less than the number of sides in the octagon. There are 8 sides in the octagon, so that means the ones digit is less than 8. The following clue is that the tens digit is less than the ones digit, so that means the tens digit must be less than 6, so it can only be 5. The final clue is that the hundreds digit is less than the number of cents in the nickel, and it is not the smallest odd number, so that means it is less than 5. But it is not 1 because 1 is the smallest odd number, so that means it must be 3. So the answer to part A is 356. Now let's move on to part B. For part B, we know that the mystery number is a 3-digit odd number, so that means the number is 3 digits, and the last digit is 1, 3, 5, 7, or 9. The second clue is all of the digits are odd numbers, so that means the first digit is 1, 3, 5, 7, or 9, and the second digit is also 1, 3, 5, 7, or 9. The third clue is that the tenth digit is greater than the number of items in half a dozen. There are 6 items in half a dozen, so that means the tenth digit is greater than 6. The next clue is that the hundredth digit is greater than the tenth digit, so that means the hundredth digit must be equal to 9. because it is at least greater than 7. This also means the 10th digit is equal to 7, because if it was 9, that would result in the 100th digit being 2 digits. The next clue is that the 1's digit is greater than the number of quarts in a dollar, so that means the 1's digit must be greater than 4. The final clue is that the 1's digit is smaller than the 10th digit, so that means it must be smaller than 7. So that leaves us with 5. So the answer to part B is 975. For this problem, we need to figure out the mystery number. We know that if we add 5 to this number, we will get the same answer as if we subtract the mystery number from 89. So that means the number plus 5 is equal to 89 minus the number. Adding the number to both sides, we get that 2 times the number plus 5 is equal to 89. We can subtract 5 from both sides and we get that 2 times the number is equal to 84. Dividing both sides by 2, we get that the number is equal to 42. So the answer to this problem is 42. For part A of this problem, you have to figure out a mystery number that is a 4-digit number. So let's draw 4 digits. The first clue is that the 1's digit is a 4, so we can put a 4 in the 1's digit. The second clue is that the 1000th digit is twice the value of the 1's digit, so that means we can multiply 4 by 2 and we get 8. The third clue is that the 100th digit is 1 less than the 1000th digit, so that means to find the 100th digit, we can do 8 minus 1 and we get 7. The last clue is that the sum of the digits is equal to 25, so that means 8 plus 7 plus the third digit plus 4 is equal to 25. We can simplify this equation and we get 19 plus the third digit is equal to 25. So that means the third digit must be equal to 6. So the answer to part A is 8764. Now let's move on to part B. For part B, we also have to figure out a mystery number that is a 4-digit number. So let's draw 4 digits. The first clue is that the 1000th digit is an even number and it is a multiple of 3. So let's list out all the multiples of 3. And we have 3, 6, and 9. Out of 3, 6, and 9, only 6 is even, so that means the first digit must be a 6. The second clue is that the 1's digit is also even and 1 less than the 10's digit, so that means the 1's digit must be 0, 2, 4, 6, or 8, and the corresponding 10's digit must be 1, 3, 5, 7, and 9, because these numbers are all 1 greater than these numbers. Now let's move on to the third clue. The third clue is that the 100th digit is 3 more than the 1000th digit, so this means the 100th digit is equal to 6 plus 3, which is 9. Now let's move on to the final clue. The final clue is that the sum of the digits is equal to 32, so that means 6 plus 9 plus the last 2 digits is equal to 32. We can subtract 9 and 6 from both sides and we get the last 2 digits is equal to 17. Now let's see which pair of the final 2 digits has a sum of 17. So we can do 1 plus 0, and we get 1, 3 plus 2, and we get 5, 5 plus 4, and we get 9, 7 plus 6, and we get 13, and 9 plus 8, and we get 17. So that means the final 2 digits are 9 and 8. So that means the answer to part B is 6, 9, 9, 8. For this problem, we have to figure out the mystery number using the following clues. The first clue is that the number is a 4-digit even number, so this means the number has 4 digits, and the last digit must be 0, 2, 4, 6, or 8. The second clue is that all of the digits are different. The third clue is that the sum of the digits is equal to 10, and each of the digits are greater than 0, so that means the last digit cannot be a 0. The fourth clue is that the sum of the digits in the thousands place and hundreds place is equal to the sum of the digits in the ones place and tens place. So this means the sum of the first 2 digits is equal to the sum of the last 2 digits. This also means the sum of the first 2 digits is equal to 5, and the sum of the last 2 digits is also equal to 5, because the sum of all the digits is equal to 10. Based on the first 4 clues, we know that all of the digits are between 1 and 4 because each of the digits are greater than 0, and they cannot be 5 or greater because the sum of 2 digits is equal to 5. So that means the first digit is 1, 2, 3, or 4. The second digit is also 1, 2, 3, or 4. The third digit is 1, 2, 3, or 4. And the last digit is 2 or 4. Moving on to the last clue, we see that the largest digit is in the thousands place. Out of 1, 2, 3, and 4, 4 is the largest digit, so that means 4 is in the thousands place. This also means 1 is in the hundreds place, because 4 plus 1 is equal to 5. Since all of the digits are different, that means the last digit cannot be a 4, since 4 is already used. So this also means the third digit is equal to 3, because 3 plus 2 is equal to 5. So this means the answer to this problem is 4132. For this problem, we have to figure out a 5-digit number. So let's draw 5 digits. Our first clue is that the fourth digit is 4 more than the second digit. So that means the fourth digit is equal to the second digit plus 4. Our next clue is that the third digit is 3 less than the second digit. So that means the third digit is equal to the second digit minus 3. The next clue is that the first digit is 3 times the fifth digit. So that means the fifth digit times 3 is equal to the first digit. The last clue is that the sum of the first 2 digits is equal to 11. The sum of the third and fourth digit is also equal to 11. And the sum of the fourth and fifth digit is also equal to 11. Using these clues, we know that the second digit minus 3 plus the second digit plus 4 is equal to 11. So we can write second digit minus 3 plus the second digit plus 4 is equal to 11. Simplifying this, we get 2 times the second digit plus 1 is equal to 11. Subtracting 1 from both sides, we get 2 times the second digit is equal to 10. Dividing both sides by 5, we get that the second digit is equal to 5. Plugging in the second digit is equal to 5 into these two equations, we get that the third digit is equal to 2, and the fourth digit is equal to 9. We know that the fourth plus the fifth digit has a sum of 11, so that means the fifth digit is equal to 2. We also know that the sum of the first and second digits is equal to 11, so that means the first digit is equal to 6. So the answer to this problem is 65292. For this problem, we have to find a 5-digit mystery number using the following clues. So let's draw 5 digits. The first clue is that the number is divisible by 2, so that means the number must end in 0, 2, 4, 6, or 8. The next clue is that the average of all the numbers is 5, so that means the sum of all the numbers is equal to 5 times 5, because there are 5 digits, and this is equal to 25. The third clue is that the last 2 digits are divisible by 7, and together the number formed by the last 2 digits is less than 70. So that means the fourth digit must be 1, 2, 3, 4, 5, or 6. And the last 2 digits are divisible by 7. Now let's move on to the fourth clue. The fourth clue is that the number is less than 50,000 and the middle digit is 7. So that means the first digit must be 1, 2, 3, or 4, and the middle digit is equal to 7. The next clue is that the first 2 digits are divisible by 11. If a 2-digit number is divisible by 11, that means the 2 digits are the same. So that means the first and second digit are the same. So the second digit can also be 1, 2, 3, or 4. The last clue is that there is only one odd digit, and since the middle digit must be equal to 7, that means the rest of the digits are even. So that means the first digit must be equal to 2 or 4. The second digit is also equal to 2 or 4. And the fourth digit is equal to 2, 4, or 6. Now let's figure out which combination of the last 2 digits can be divisible by 7. And we see that only 2 and 8 and 4 and 2 are divisible by 7. So that means the last 2 digits must be 2 and 8 or 4 and 2. We know that the sum of the 5 digits is equal to 25, and we can use this clue to help us solve this problem. We can split the sum of these 5 digits into 2 separate sums. they would be the sum of the first, second, and third digit, and the sum of the fourth and the fifth digit. So let's figure out all the possible sums of the first three digits. They would be 2 plus 2 plus 7, which is equal to 11, and 4 plus 4 plus 7, which is equal to 15. Now let's figure out all the possible sums of the last two digits. They would be 2 plus 8, which is equal to 10, and 4 plus 2, which is equal to 6. Now let's figure out which two sums added together is equal to 25. In this case, they would be 4, 4, and 7, and 2 and 8. So that means the first three digits are 4, 4, and 7, and the last two are 2 and 8. So this means the answer to this problem is 4, 4, 7, 2, 8. For this problem, we have to find the 5-digit mystery number that fits all of the conditions below. So let's draw 5 digits. Our first clue is that the sum of all 5 digits is equal to 23. So that means the sum of these digits is equal to 23. Now let's move on to the second clue. The second clue is that the second digit is 3 times larger than the first digit. So that means the second digit is equal to 3 times the first digit. The third clue is that the third digit is 2 smaller than the first digit. So that means the third digit is equal to the first digit minus 2. Now let's move on to the fourth clue. The fourth clue is that the fourth digit is 5 greater than the first digit. So that means the fourth digit is equal to the first digit plus 5. The final clue tells us that the last digit is 4 times the first digit. So that means the last digit is equal to 4 times the first digit. And obviously the first digit is equal to the first digit. So let's simplify this equation, and we get that 10 times the first digit plus 3 is equal to 23. Subtracting 3 from both sides, we get 10 times the first digit is equal to 20. Dividing both sides by 10, we get that the first digit is equal to 2. So let's plug in the first digit is equal to 2 for all of these digits. So we have the first digit is equal to 2, the second digit is equal to 6, the third digit is equal to 0, the fourth digit is equal to 7, and the last digit is equal to 8. So the answer to this problem is 26078. For this problem, we have to find a 6-digit number that contains no zeros and no repeated digits that satisfies the following conditions. So let's draw 6 digits. Based on the first clue, we know that the first and fourth digit sum up to the last digit as to the third and fifth digits. So this means the first digit plus the fourth digit is equal to the sixth digit. This also means the third digit plus the fifth digit is also equal to the sixth digit. Now let's move on to the second clue. The second clue is that the first and second digits, when read as a 2-digit number, equal 1/4 of the fourth and fifth digits. So this means the first and second digit times 4 is equal to the fourth and fifth digit. Now let's move on to the final clue, which is that the last digit is 4 times the third digit. So this means the last digit divided by 4 is equal to the third digit. This also means the last digit must be a 4 or an 8, because only 4 and 8 divided by 4 would result in a whole number. So let's test if the last digit can be a 4. The only ways to get a sum of 4 is 1 plus 3, 2 plus 2, and 3 plus 1. And we must be able to get 2 ways to get a sum of 4 without repeating digits. And this is impossible, as you can see here, because if we choose 1 and 3 and 3 and 1, 1 and 3 are repeated. But if we include 2 and 2, then 2 is repeated. So this means the last digit must be an 8. So we can delete this 4. We know that the third digit is equal to 8 divided by 4, so the third digit is equal to 2. And now we can plug in 2 and 8 into this equation. So we have 2 plus the fifth digit is equal to 8. so this means the fifth digit must be a 6. Now let's figure out the first digit. We know that the first and second digit times 4 results in a 2-digit number, so this means the first digit must be a 1 or a 2, because if it was a 3 or greater, that would result in a 3-digit number. We also know that the first digit plus the fourth digit is equal to the sixth digit, which is 8. If the first digit was a 2, that means the fourth digit must be at least an 8, and that would have a sum of at least 10, which is greater than 8, so this means the first digit must be a 1. If the first digit is a 1, we can solve this equation. We can plug in 1 and 8, and we have that 1 plus the fourth digit is equal to 8. Solving this equation, we get that the fourth digit is equal to 7. Now let's figure out the second digit. We know that the first and second digit times 4 is equal to the fourth and fifth digit. We can plug in 76 for the fourth and fifth digit, and we have the first and second times 4 is equal to 76. Dividing both sides by 4, we get that the first and second digit is equal to 19. So this means the second digit is equal to 9. So the answer to this problem is 192768. For this problem, we have to figure out the 5-digit mystery number that fits all of the conditions below. So let's draw 5 digits. The first clue tells us that the sum of the first 2 digits is 1 smaller than the third digit. So this means the first digit plus the second digit plus 1 is equal to the third digit. The second clue tells us that the third digit is double the fourth digit, so this means the fourth digit times 2 is equal to the third digit. This also means the fourth digit must be 1, 2, 3, or 4, because any number greater than 4 doubled would result in a 2-digit number. So this also means that the third digit is 2, 4, 6, or 8, because 2, 4, 6, and 8 is 1, 2, 3, and 4 doubled. Now let's move on to the third clue. The third clue is that the fourth digit is double the last digit. So this means the fourth digit divided by 2 is equal to the last digit. So this means the last digit must be 1 or 2, because only 2 and 4 divided by 2 results in a whole number. So this means we can remove 1 and 3 from the possibilities of the fourth digit and 2 and 6 from the possibilities of the third digit. Now let's move on to the fourth clue. The fourth clue says that the third digit is the product of the fourth and fifth digits. So this means the third digit is equal to the fourth digit times the fifth digit. Now let's test all the possible combinations for the final 3 digits. The final 3 digits can be 4, 2, and 1, or 8, 4, and 2. So let's plug in these numbers into this equation. So we have 4 is equal to 2 times 1, which is false. So this means the final 3 digits cannot be 4, 2, and 1. Now let's test 8, 4, and 2. So we have 8 is equal to 4 times 2. And this is true, so that means the final 3 digits is equal to 8, 4, and 2. So let's remove 4, 2, and 1. Now let's move on to the fifth clue. The fifth clue says that the second digit is 5 more than the first digit. So this means the first digit plus 5 is equal to the second digit. We can solve for the first and second digit using these two equations. We already solved for the third digit, so we can replace the third digit with 8. From this equation, we see that the first digit plus 5 is equal to the second digit, so this means we can replace the second digit in this equation with the first digit plus 5. So we have the first digit plus the first digit plus 5 plus 1 is equal to 8. We can subtract 6 from both sides, and we get that 2 times the first digit is equal to 2. So this means the first digit is equal to 1. Now we can plug in 1 into this equation, and we get that 1 plus 5 is equal to 6. So this means the second digit is equal to 6. Now let's see the final clue. The final clue is that the first digit is 1/8 of the third digit and also 1/4 of the fourth digit. So let's check if this is true. and we see that 1 is 1/8 of 8, and 1 is 1/4 of 4, so this means that is true. So the answer to this problem is 16842. For this problem, we have to figure out a 5-digit number that satisfies the following requirements. So let's draw 5 digits. Based on the second clue, we know that the first 2 digits are the same. Based on the third clue, we know that the fourth digit is twice the first. So that means the first digit is 1, 2, 3, or 4, because any number greater than 4 doubled would result in a number that is 2 digits. This also means the second digit is 1, 2, 3, or 4, because the first 2 digits are the same. The fourth digit would be 2, 4, 6, or 8, because that would be the first digit doubled. Now let's move on to the fourth clue. The fourth clue says that the last digit is twice the third. So that means the last digit can be 2, 4, 6, or 8, and the third digit is 1, 2, 3, or 4. Our last clue tells us that the sum of the digits is equal to 18. We can figure out the sum by splitting it into 2 parts. They would consist of the first 2 digits, and the fourth digit, and the third digit, and the last digit, because these digits are related. So let's figure out all the possible sums of the first 2 digits and the fourth digit. They would be 1 plus 1 plus 2, which is equal to 4, 2 plus 2 plus 4, which is equal to 8, 3 plus 3 plus 6, which is equal to 12, and 4 plus 4 plus 8, which is equal to 16. All the possible sums of the third and final digit would be 1 plus 2, which is equal to 3, 2 plus 4, which is equal to 6, 3 plus 6, which is 9, and 4 plus 8, which is equal to 12. Now we have to figure out which number from this column and this column have a sum of 18. In this case, it would be 12 and 6. Remember that this column is the first digit, this column is the second digit, this column is the fourth digit, this column is the third digit, and this column is the fifth digit. To figure out the answer to this problem, we will plug in each of these numbers into their corresponding place, and we get 3, 3, 2, 6, 4. So the answer to this problem is 33264.